Hello everyone, this is the final video in our tutorial series. Of course, I didn't and can't cover every single concept in C and C++, but if your goal is to learn how to use C and C++ for programming, I believe this series is more than enough to get you started. Okay, for our final topic, we are going to talk about templates. Okay, and templates allows both classes and functions to share a unified interface. When applied to functions, templates provide function overloading behavior. And when applied to classes, they give multiple classes a common extensibility. Sounds a bit abstract, right? Let's jump right into some examples. As mentioned, templates are mainly applied in two areas, functions and classes. To define a function template, we start with template keyword and follow it with angle brackets. And inside the brackets, use the type name keyword to define a type alias, which acts like a placeholder for an actual data type. Let's call our placeholder T. Here's a simple template function that performs addition. Okay, now let's test it in main function by passing integers, strings, and floating point numbers. Okay, let's run this and see the results. Okay, you can see that regardless of the type we pass in, the function executes correctly. This is because template function treats all input arguments as the same type, T. If both arguments are integer, then the return type is integer. If both are strings, the return type is string, and so on. But what if we want the return type to always be a string, no matter what the inputs are? We can define an additional type alias for the return type. Okay, notice that if you use std2string function, you have to include the header file string. Okay. Now in main function, we must explicitly specify the return type, since the compiler won't infer it automatically. Okay, notice that the type written inside the angle brackets corresponds to the aliases in the order we declared them. For example, R is the return type, so it is the first argument in the brackets, and T is deduced automatically from the function parameter. Okay, let's run this and see the result. You can see that all results are returned as concatenated strings. Now let's move on to class template. Class templates allows us to extend different classes with a common structure and behavior. Here are two simple classes that I had completed. One class stored an integer and the other stores a string. Both provide getData method. Now let's design a template class that can extend both of these classes with a unified behavior. Okay, here C is the input class type, and T is the data type returned by getData. And the add method simply doubles the value by adding it to itself. Okay, in main function, we can apply this class template like so. Okay, here's what happens. A is initialized with the value 10, and B is initialized with the string hello. And we then wrap each object with the extension template class. And finally, calling add function doubles the values, one as an integer sum, the other as a string concatenation. Okay, let's run this and see the result. You can see that 20 for the integer class and hello for the string class. This demonstrates how class templates can give otherwise unrelated classes a common interface. Okay, in this video we introduced templates covering both function templates and class templates. Templates are extremely powerful and widely used in modern C++. With practice, you will see how they allow flexible, reusable, and type-safe designs. Let's wrap up our tutorial series. Thank you so much for your support, your comments, and your questions. I will keep an eye on your feedback. And if there's an opportunity, I will create more tutorial series in the future, or add some supplementary lessons where needed. Thanks again, and see you next time.